There are different ways to define the trigonometric functions, and in a previous video we talked about how to go about it using right triangles. You should view that video first if you haven't already. For this video, instead of using an angle contained in a triangle, we will place the input angle on x and y axes. We'll start by drawing the input angle in standard position on the axes. The angle could be measured using either degrees or radians, and you should think of the angle as a rotation rather than a static measure. We'll start the rotation from the positive x-axis, which is considered the initial side for the angle, and then we'll wind around counterclockwise. We'll draw what is called the terminal side, where the angle ends. To get the output values for the trig functions, we need to identify the coordinates of an xy point on the terminal side. Any point will do, as long as it's on the line. Then we'll figure out the distance from the origin to that point. This is commonly called the radius, represented by r. Then with these three numbers, x, y, and r, we can form the trig function outputs. Here's how. Notice that if we use an angle between 0 and 90 degrees, our terminal side will be in the first quadrant. If we add a vertical segment from the xy point, we can create a right triangle that contains our angle. This means that we could use the right triangle definitions we already know, but notice that the length of the hypotenuse is the same value as r, the radius. The adjacent side length matches the x value, and the y value matches the opposite side length. With these equivalencies, we can easily translate our right triangle definitions to ratios that involve x, y, and r instead. When we used right triangles, we were limited to input angles between 0 and 90 degrees. With this new definition, not only can we handle angles larger than 90 degrees, we can use inputs like 0 or 180 degrees, or even negative angles, which means we wind the opposite direction, clockwise. We can even use angles that are more than one complete rotation. One big difference you'll notice now that we have a wider variety of possible input angles is that we'll sometimes get negative output values for the trig functions, or even undefined results. That didn't happen with triangles. As an example, here's an angle drawn in standard position, and a point on its terminal side is given. We don't need to know the measure of the angle here to get the trig function values, although later you'll learn ways to figure that out if the angle's measure is needed. We do need the radius value, which we can get by using the relationship x squared plus y squared is r squared. This should look familiar to you from equations of circles as well as the Pythagorean theorem. Now that we know x, y, and r, the trig function outputs are quick and easy.